This is a demonstration of how Tibco Spotfire can enable a retailer to design and run a real-time targeted cross-sell campaign to maximize revenue lift. The capability demonstrated here is related to areas of market basket analysis, affinity analysis, and incremental or uplift modeling. This represents a solution that we built for a real retailer, but in this example, the retailer is fictional and the data is simulated. In this example, we have 6.5 million rows of data loaded into Spotfire Professional, and each row represents a transaction in recent history in this national chain of 250 grocery stores. The data has been pivoted by product category, so you can see there are 88 columns that represent 88 product categories, and each cell represents the spending in that category for that transaction. In each row, we also have a transaction ID and a store ID. The first step is to select a product category that we are interested in promoting with a cross-sell campaign. In this example, we will choose gift cards because gift cards are typically a high-margin item for retailers, partly because many people forget to redeem them. As a retailer, if you can successfully cross-sell gift cards, you can often dramatically increase your revenue. We want to target opportunities to cross-sell gift cards based on other items in the customer's basket when they check out. In the language of statistics, gift cards is our response variable. It represents the behavior we want to predict. When we choose gift cards, Spotfire uses a technique called oversampling to boost the proportion of gift cards in our sample. This is important because gift card purchases are relatively rare, occurring only about 1 in 100 transactions. Logistic regression has been shown to underestimate the probability of rare events in many cases. So when we use oversampling, we apply corrections to ensure that the model coefficients are the same as they would be in a non-sampled situation. And the logistic regression actually gives us better accuracy than we would get without oversampling. It also saves memory and CPU time. We are sampling to get about 50,000 rows of data, and among those, about half of the transactions include a gift card purchase and half do not. We want to identify other categories of products that customers very often buy at the same time as they buy a gift card. The idea is that will give us a picture of what a gift card buyer's basket typically looks like. Then, if we find a customer who has a basket that looks like they would buy a gift card but they have not, we would say that customer has a high propensity to buy a gift card. A customer like that is the best customer to extend an offer to buy a gift card. They are easily persuaded, so they would often require only a very small incentive to do so. This practice of targeting only the persuadable customer is sometimes referred to as uplift modeling or incremental modeling. Here, we can browse through the 88 product categories to see which of them are often in the same basket as a gift card at the checkout. In the language of statistics, these are our potential predictor variables. These represent the data that we might use to predict whether someone is likely to purchase a gift card. When there is no strong correlation between gift cards and the selected predictor, all cells in this cross table will be about 50%. When a predictor shows a strong positive or negative correlation, the percentage will no longer be weighted evenly. In our overall sample, 50% of transactions included a gift card. If we look among the transactions that included office supplies, in the right column of this cross table, we see that 71% of them included gift cards, indicating a strong positive correlation. Instead of manually sorting through each of these categories, we are going to use Tibco Enterprise Runtime for R to automatically rank by how strongly they predict gift card purchases. Tibco Enterprise Runtime for R, abbreviated TERR, pronounced TER, is Tibco's high-performance statistical engine. It's compatible with the open-source R language for statistical computing, and it's built into Spotfire. So, under the hood, TER performed a statistical test called a chi-square test and did that 87 times, comparing gift cards to each of the other product categories. Immediately, we see that greeting cards comes to the top, and this makes sense since a customer may buy a greeting card, then stuff it with a gift card to give as a gift. Looking at the bar chart on the right, this represents the relative strength of each of these predictors, and we can see that nothing else comes close to the predictive power of greeting cards in predicting gift card purchases. But there are a number of other predictors that seem to show some positive correlation. We can also look at what categories of products are least often purchased with a gift card. Gasoline tops that list because it's typically purchased at a station outside of the store. There are several other categories, such as produce, that seems to be rarely purchased at the same time as a gift card. We want to take some of these insights and build them into a formal predictive model. Here we are going to use a logistic regression model which will predict whether or not someone buys a gift card based on the dollar amount spent in other product categories. Let's select which predictors we want to include in our model. These are still in order with the strong positive correlations at the top and the strong negative correlations at the bottom. Let's select a few of the strong positive predictors and a few of the negative predictors, so we get a simple model that has a lot of predictive power. When we press this button, TERR builds a logistic regression model based on this data. If you have selected any predictors which do not turn out to have any statistical significance, they are automatically excluded from the model using a technique called backwards stepwise variable selection. So here, Spotfire visualizes the relative importance of each of the predictors in the model. If we look at the bar representing greeting cards, what this tells us is about 4% of the variation in our response variable, that is, whether or not customers are buying gift cards, is explained by the dollar amount that is spent on greeting cards in the same transaction. For greeting cards, that's a positive correlation, so you see a positive bar. The dollar amount spent on gasoline also explains about 4% of the variation in our response here, but the association is negative, and it can be important to include negatively associated predictors in a model like this because they may represent transactions where the customer will have an adverse reaction to being given a cross-sell offer. These customers are sometimes called sleeping dogs in the parlance of uplift modeling, and the most profitable action is to just leave them alone. There are many kinds of descriptive and diagnostic model outputs we can show in Spotfire. You may choose to display them or not based on how statistically savvy your users are. We can look at details of the model coefficients and the analysis of variance or deviance. The correlation matrix is one diagnostic output that's represented visually, and it's fairly easy to understand. It is important in a regression model not to include two or more predictors if they are highly correlated with one another. That's a problem called multicollinearity, which can make many of the conclusions of your model invalid. In this correlation matrix, if you were to see any such high correlations between predictors, they would appear as dark cells off the diagonal. We do not seem to have any significant issues with multicollinearity. Some tests like this could also be automated so that the user sees a warning instead of having to diagnose the problem from a visualization like this. Now that we have created a model, we want to immediately understand what kind of revenue lift opportunity exists if we were to run a cross-sell campaign to target offers for gift cards. So TERR, Tibco Enterprise Runtime for R, has taken our model and generated predictions of how many transactions there are at each of the 250 stores in our chain where the basket looks like one that should include a gift card but does not. That is, how many daily instances of a persuadable customer do we identify at each store for this offer? So TERR takes the model predictions, ranks the store in order, and calculates each store's contribution to revenue lift. We can set some parameters of the campaign. For instance, we can determine how many stores, what duration, quantify the fixed costs associated with running the campaign, perhaps for training staff on how to extend or redeem the offers, how to stop fraudulent or exploitative redemptions, or perhaps relocating inventory on the floor to make logistics of the offer simpler. There's also an option to include a cost for extending the offer and a cost for accepting the offer. For instance, if the offer was for a free coffee at the coffee shop at the front of the store, that might cost 75 cents for the retailer. Even though with our model, we are only targeting customers who are modeled as having a high propensity to accept an offer for a gift card, many of these customers will still not accept the offer because they are essentially being coerced to accept an offer and not naturally choosing it. We factor this offer acceptance rate into the revenue lift calculations. We can also choose what the average purchase amount of the gift card is when the offer is accepted. All these parameters factor into how much revenue the offer generates. Spotfire visualizes the predicted cumulative revenue lift from running the campaign in more and more stores. We also see the stores visualized on a map. The size of each point represents the size of the contribution to revenue lift that the store generates. We can see that we definitely do not want to run this campaign as is in all our stores. If we were to do that, we would result in a loss. What we want to do is maximize our revenue lift by running it in only the stores that give us a positive revenue lift. We can see each of the stores has its revenue contribution listed here, and we want to essentially bring this cumulative revenue lift curve directly to its peak and no further, or change some of the parameters with the campaign. For instance, extend the duration such that the peak revenue lift is higher. A variety of what-if analysis can occur here based on experience with what is a realistic set of parameters for a campaign and what is the revenue lift we are looking for. We now have a predictive model, and we found the parameter values that might maximize the predicted revenue from running a cross-sell campaign that uses this model to target offers. The next step might be to publish this model so it is ready to be promoted to production for use in a real-time cross-sell campaign. We want our point-of-sale system to integrate with a system that can make predictions based on this model. The mechanics of publishing this model are very simple. In fact, we have already published the model. You may have noticed that back when we predicted the model, it was assigned a unique model ID number. Every time we fit a model in this application, it is assigned a unique ID. It is archived on a Tibco Spotfire Statistics Services server, and there the model is immediately ready to be used. Tibco Spotfire Statistics Services has several APIs that can enable many applications to call it in order to make statistical predictions based on a model such as this. For example, Tibco Business Events, which is Tibco's Complex Event Processing or CEP software, or Tibco Active Matrix BusinessWorks software, which is an automation integration platform, could be configured to call Tibco Spotfire Statistics Services to generate predictions based on this model. To demonstrate how this predictive model can be used for real-time scoring to predict propensity of a customer to accept an offer to purchase a gift card based on the other items in that customer's basket at the point of sale, we will use a small standalone tool that simulates transactions, sends those transactions to the model on Tibco Spotfire Statistics Services, and then receives predictions back. We load a small sample dataset of 10 transactions. This data is in the same format as the data we were analyzing inside Spotfire. Each row represents one transaction, and there is a column for transaction ID and store ID, followed by 88 columns representing the spend in each of the product categories in that transaction. We can see greeting cards is one of the columns that was a variable that was shown to have a high correlation with gift card purchases. 2 of these transactions include greeting cards, so we can see whether the outcome corresponds with our expectations given what we know about the model. Enter the model ID copied from Spotfire into this field, and then we can begin to simulate these transactions. Now that this small simulation of 10 transactions running through this predictive model has finished, we can see the outcome. In 2 of these 10 cases, the model predicted that the customer had a greater than 50% likelihood of accepting an offer for a gift card based on the other items in their basket. So 2 offers were extended out of these 10. Setting the propensity threshold to 0.5 means that offers will only be extended to customers when they are predicted by the model to be more likely to purchase a gift card than not, based on the other items in their basket. In practice, we could automatically set up an ideal threshold based on some of the parameters of the campaign, some pre-specified limits, and we could also dynamically adjust this as the campaign is running based on how many redemptions there have been so far and other performance parameters. The user of the Spotfire application would need to communicate with people who can set up the logistics of a cross-sell campaign before deploying the model. Cross-sell campaigns, especially for consumer packaged goods, are often tied to manufacturer sales incentives. There is a lot of administrative overhead and a lot of difficulty getting information like this information about these predictive models into the hands of the person who makes the decision ultimately to run a cross-sell campaign. To enable that collaboration, Spotfire integrates with Tipper, which is Tibco's enterprise social network. In the Spotfire collaboration panel, we can share findings, put this information into context in order to collaborate, and take the next steps to move this model from insight to action. Thank you for watching this demonstration of how Tibco Spotfire can enable a retailer to maximize cross-sell campaign revenue lift. For more information, please contact our Marketing Development Specialist group at mds@tibco.com.